Hello, my name is Daniel Suh, and my personal project is extending the HACKberry prosthetic arm. Typically, the user equips a simple muscle sensor connected to the microcontroller board through a stereo jack. If the arm muscles are contracted, the hand closes. On the other hand, if the arm muscles are relaxed, the hand opens. After testing this functionality, I realized that users could have trouble picking up objects for a long duration of time. This is because the more the user maintains the closing of the hand, the more strain on the user's arm. Here's my solution. Simply put, using AI object recognition, depending on the object detected, a specific code for picking the object up will be initiated. This solution will require no physical strain on the user's arm while simultaneously performing the task at hand. In order to fulfill this goal, I realized I would require three major components: a microprocessor, a microcontroller, and a camera attached to the arm. Killing two birds with one stone, I deduced that my Raspberry Pi will be able to fulfill the role of a central processing unit, while the Pi camera attached to it will provide a set of eyes for my object detection. As for the microcontroller, I was stuck between the Arduino Uno and the custom HACKberry microcontroller board. Ultimately, I decided that the Arduino Uno would be a better fit. Not only did the Arduino provide digital pins to connect to a breadboard via jumper cables, but its endurance was far superior compared to the HACKberry microcontroller board. The HACKberry microcontroller board was based on the Arduino's design anyway, so the transition was smooth. To ensure that communication between the Raspberry Pi and Arduino Uno was reliable, I completed a mini project where a line of Python code in the Raspberry Pi would command the Arduino to light an LED up. Next step was to install OpenCV. Installing it on the Raspberry Pi took literally an entire day. My coding preparation for the Raspberry Pi was now complete. Once OpenCV finally installed, I was able to write and finalize my Python and Arduino codes. For the Python code, I first made a serial connection to the Arduino Uno that is connected to the Raspberry Pi. Weights and configuration files are also referenced as well. Basically, the code identifies and draws a red rectangle around the object detected continuously in a while loop. Depending on the object, the code also communicates specific binary data to the Arduino serial ports. For example, if an apple is detected, the binary number 2 is communicated. An LED is lighted up as well to show visual evidence that the code is working. As for the Arduino code, the code is relatively simple. Using the example from earlier, once receiving the specific binary number 2 from the Raspberry Pi, each of the fingers are moved to a specific angle that is ideal for holding an apple. Since the orange detected is small, the code is designed to hold a small circular object. In the near future, I hope to connect with XI Incorporated to make my solution a reality for their prosthetic design. But for now, I plan on uploading my codes on their GitHub forum to possibly help others with HACKberry processes. For more information, please check out my blog. Thank you for watching.